All right, continuing where I left off in the last video, let's look again at f of x equals x squared going from r to r. All right, so the x-axis is the real line, the y-axis is the real line. Like I talked about in the last video, lots of, pretty much, or let's just say lots of applications require functions that exist in higher dimensional space. So such a high dimensional space that we can't graph them. The only way we can think about them is in the abstract. So, but before we do that, let's look at transferring something we can see into the abstract form of looking at it. All right, so the way we do that is we have our domain, let's say D. We have our target, T, and our function f from the domain to the target. In this case, the domain is the real numbers. The target is the real numbers. So I'll just write that. All right, now we can't list all of the points here because there's infinitely many of them. So I'll just list a couple of them. Let's say this is 1, -1, 2, -2, and let's just do another one. 0, there, there, and there. Let's say 1, 4, 0, -1, -4. All right, now there's many other points in here, right? Infinitely many. I'll put ... like so. Okay, so we represent this in an abstract way. Oops, okay. My bad. Like that. -1 goes to 1 as well, as we know, right? If you think about that, how does that look? You got 1 and -1. They both go to 1. Represent that with a point and a point, something like that. Okay, both 2 and -2 go to 4. 0 goes to 0. And notice there's nothing that comes over to -1 and -4. Okay, let's do these other ones too. Sorry about that. Let's see. Okay. Put on that thing. Go like that. Okay, got 2 and -2. There's 4. 2 goes up. Put 2 over there now. I can do that. No big deal. Go like so. Okay, so 4 goes over. There's your 2. Okay. So that's what we see here. So like so what I got going over here in this abstract way, -1 and 1 going to 1, that's exactly represented right here. So 1 goes up to 1, -1 goes up to 1, like that. So you can think of this is the x-axis, and this is the y-axis. All right, now something you've probably noticed is that maybe you've noticed is that not every real number here gets hit, right? Not every one of these numbers here, these ones, and also none of the negatives, none of those have any. So nothing comes over to them. There's just nothing that comes over to them, or in other words, and we see that here if you go into the negative. Let's say we look at -1 there, -1 on the y-axis there, right? There's no x's whose f of x value touches that, right? The graph would have to come down there somehow, to come down to -1. The graph would have to cross this horizontal line for -1 to be hit by the function. All right, so these values that get hit by the function, that's what we call the range. That's what we call the range. And the range is a subset of the target. And it's a loose correlation, or a loose metaphor or what have you to a dartboard, and that's kind of why we call it the target, right? If you think of throwing darts at a dartboard, right, you might throw a dart and it might hit there. A dart might hit there. You might actually get close to the bullseye. Yes, I want to. But when you're throwing darts at a dartboard, you're never going to hit the whole thing. And so the range is all the places, all the dots where you got hit. The target is all possible places, and you can never hit all of them. First of all, you don't have enough darts. Second of all, there's just way too many of them, way too many points in the target. You would never hit them all. And so the range is all the places that get hit, and the target is the whole dartboard. All right. And so from that idea, so the range is always a subset of the target. Always. The range is always a subset of the target, by definition. Sometimes we have functions where everything does get hit. An example of that would be f of x equals x cubed. Here, the range equals the target. So, by definition, so what I'm saying here is, by definition, the range is always a subset of the target. In the case of f of x equals x squared, the range is a proper subset of the target. Not everything in the target gets hit. You think of this as the dartboard. These arrows kind of look like darts. And it's like you're throwing this -1, or the 1 and -1 dart, they hit 1. The 2 and -2 darts hit 4. The 0 dart hits 0. But not all of the target, not all of the real number dartboard gets hit. -1 doesn't get hit, -4 doesn't get hit, -√2 doesn't get hit, right? +√2 gets hit. But in the case of f of x equals x cubed, the range equals the target. Everything in the target gets hit. And that's all I'm going to say there.